coming at you like a whirlwind, 100 miles an hour with apprehension. Did I mention you gotta pay attention? Here we go, check the flow. Geometry 6-4. Rectangles, baby. Alright, a rectangle is a parallelogram with 4 right angles. A rectangle has the following properties. We know all 4 angles are right angles, and then just like a parallelogram, opposite sides are parallel and congruent. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other. And the diagonals of a rectangle are congruent. Alright, so if a parallelogram is a rectangle, 613 says the diagonals are congruent. Here we go. A rectangular park has 2 walking paths as shown. If PS is 180 meters and P to R is 200 meters, find QT. Okay, well, we know that PR is equal to QS because this is a rectangular park and diagonals are congruent. So we know that QS is also 200 meters. Since diagonals bisect each other, we know that QT is 100 meters. All right, quadrilateral JKLM is a rectangle. If KJL, that's this angle, KJL, is 2x plus 4, and JLK, that's this angle here, JLK, is 7x plus 5, find x. So it helps to label the picture. So if you're working on this draw picture, label it. So we'll put in the 2x plus 4 right here and 7x plus 5 there. Now there's several ways you can solve this. One of the ways is we can look at this as a triangle, and we know that this is a rectangle, so we know that this angle up here is 90 degrees. Okay, so we know that these 3 angles together add up to 180 degrees. So starting there, we know that this angle, JKL, this one's 90 degrees. Plus the other 2 gives us a triangle of 180 degrees. So simplify, combine like terms, we get 9x plus 99 is 180. Subtract 99 and we get 9x equals 81. And then divide, we get x equals 9. All right, 614 says if the diagonals are congruent, then the parallelogram is a rectangle. So if these are congruent, then we know that it is a rectangle. All right, so here we have a community center. It's created an outdoor dodgeball field. To be sure that it meets the ideal playing field requirements, they measure the sides of the field and its diagonals. If AB is 60 feet, BC is 30 feet, CD is 60, AD is 30, AC is 67, and BD is 67. Explain how they can be sure that the playing field is rectangular. Well, if we inscribe all that information, we know that opposite sides are congruent, 60, 60, 30, 30, and we know that the diagonals are congruent, AC and BD. So we know that this is a rectangle. All right, here we go on a coordinate plane. PQRS has the vertices -5, 3, 1, -1, -1, 4, -4, -7, and 0. Determine whether it is a rectangle by using the distance formula. Now, when you graph this, you can have a look at it and see, okay, well, you could figure out the slopes and go that way. We're going to use the distance formula. Distance formula right here. So we know PQ is the square root of 52. And RS is also the square root of 52. So we know that these two sides are congruent. All right. And then let's see, PS, this one is square root of 13. And then if we work out QR, that's also the square root of 13. So we know we definitely have a parallelogram here. We just want to determine, we know opposite sides are congruent. That's a parallelogram for sure. We want to know, is it a rectangle? So we also have to determine the diagonals. So we're going to do the same thing, distance formula for PR and distance formula for QS. And those are equal. Since the diagonals are equal and opposite sides are congruent, we have a rectangle. And that's all for today, folks. Remember to like and subscribe to the Mastermind channel.